Good afternoon, students. Today we're going to be working with MonoGame input. So we have a starter project, and this is going to work a little bit differently than you've probably done in the past, where you have probably used GitHub Classrooms. That is being done away with by GitHub. So we are going to replace that process with using template repositories in this course. So this is our template repository, Input Exercise 2026. It's in the CS580 organization. And you'll notice it looks like a standard repo. We have our code window and everything, but instead of the fork option up here, we have a use this template. So a template repo will allow you to create a brand new repository with exactly the contents of this repo, but it's not a fork, so it doesn't tie back to the old repository once it's been created. We're going to go ahead and create a new repository here, and it'll take just a moment to pop up. It's going to ask you what you want to call this. I'm going to go ahead and call it Input Exercise. You don't have to call it that, but it's a good idea to use the same name. And I'm going to skip the 2026. That was just to relabel, so my old ones stick around. But this is going to be your project for the input exercise. And then you can go ahead and say create the repository. Want to make sure that this is a public repository so that it can actually be graded. If it's not public, then when you turn in your URL, I won't be able to see it. It will be as though it doesn't exist, and you'll get a 0 on the assignment for turning in nothing. So be sure that you actually do make it public, or failing that, you need to add me and the TA. Use our GitHub usernames to your project. It's easiest just to make those public repositories. Okay, so you'll notice that goes ahead and creates a repository now in your account that is a match for what we just worked on. And then we can go ahead and clone that like you're used to. So I'm going to use the SSH option. You can use whatever is most comfortable to you. And again, I like to work at the command line. So I will go ahead and clone it at the command line. But you can also do that through one of the Git GUIs if you prefer. And now I'm going to jump into that directory and open it in Visual Studio Code. Alright, so we have our project cloned. We'll real quickly look through it and see what's going on in there. So we have our standard program.cs, not very different other than the name of the game that we're going to use. This is input example game. And you can see in here we have a new variable that isn't there when we use the template. This creates an array of these ball objects. And then in our initialize, we are populating that with 3 balls. And notice the constructor, we're passing the color red, and we're also passing in the position vector as one of the property arguments, initialization arguments. So this is going to set construct a ball using color red and give it a position. We can jump into our ball and take a look at what that constructor does and what those properties do. So you notice it has a private game, input example game variable, a private color variable, a private texture 2D, and then a public position vector. That's the one we're setting. And then our constructor takes both the game and the color and stores them in private variables so that we can access it later. We also have a load content method, which just calls this load content for the basketball, and it does that using the content manager that belongs to the game. And then the draw, we have a check to see if this texture is null. Just so you know, if you try to call spritebatch.draw with a null texture, it will actually crash your game. So this is a pretty straightforward check just to make sure it's been loaded before we call draw, and then we call draw. So this is a very simple class. Let's jump back to our game. So we've initialized that here, and also we're passing in this as in this instance of the input example game class. That's what gets stored in that private game variable. In the load content, we are going to iterate over each ball in that array and call its load content. So that will invoke that method we saw here, where it's going out and going to the file, loading that basketball .x file that we create from the content manager. Now you might be thinking, well, you're doing file I/O and you're doing that in each one of these balls. here when we iterate over that array, and isn't that horribly inefficient? And normally you'd be correct, but the way that the content manager actually works is it will load each item once, and it loads them into a dictionary and caches those for later on. So the actual identifier, that string that we passed in, is essentially a key to a dictionary. So the next time we ask for the ball, it just uses the cached version. So this is actually very efficient and works pretty well for us. And then we have our update method has no changes, and our draw method, we have a sprite batch begin and end call, and in between those we are invoking the draw method of the balls itself and passing in that initialized sprite batch. So this is a common pattern we'll use where we actually create sprite objects to represent our sprites, and we have draw methods and update methods on them as well, like we'd normally also loop through and call our update here, except our balls don't change at all, so there's nothing to do to update them. And that's pretty standard, pretty straightforward. Let's go ahead and take a look at this running. So I'm going to open my terminal and go ahead and trust that folder and do .NET run. And it'll take a moment to restore because this is a brand new install of that project. And here is our game window. So you can see we have 3 balls. They're drawn in slightly different positions towards the center of the screen. That corresponds to these 3 constructors. So what we want to do today is actually work on bringing some input into this game and actually doing something interesting with these balls. So all of the input stuff comes from the input namespace, which we've already pulled in. So we're pretty much good to go there. And I'm going to go ahead and create a protected instance of a keyboard state. And one of the things that's a little different about MonoGame than probably a lot of the input that you have dealt with in the past is it uses a polling way of handling input rather than an event-based approach. So in an event-based approach, we wait for the OS to tell us something has come in as input, and we process it. With a polling approach, what we actually do is go grab what is the current state of the keyboard at this moment, because I want to see that and I want to use that. And you can see here, here we have keyboard get state is keys down, keys escape. We're actually calling that function to grab that state. Now, rather than grabbing that state every time we want to check input, it makes a lot more sense to cache that. So we're going to say this current keyboard state equals keyboard.getState, and we're only going to call this once in our at the start of each update loop. So then we can replace this keyboard.getState with that current keyboard state, and then we can also do our own input processing with other inputs. So we're going to start by adding movement controls to the first ball with that keyboard state. And the keyboard state has an isKeyDown method, which will return a Boolean, which is true if a particular key is pressed down and false if it's not. The particular keys are specified by this keys enumeration. So let's do the up arrow. And then we might also want to do the A key if we're doing WASD. That's common, so if we wanted to capture either or, we can do it that way. And then if either one of those buttons is pushed down, we want to move our ball upwards. So we're going to say balls 0.position, and we want to change this in an upward direction. So we're going to plus equals, and I'm going to use vector 2 unit y is going to have 1 up, or we could actually do a new vector 2. Now we do want to add a vector to the vector. We don't want to try to manipulate the x or y directly, because if you do dot y plus equals, in fact I can show you that, this is actually considered an error because this is a struct. We're not allowed to modify individual properties with the plus equals. So instead, what we're going to do is we're just going to add a vector to the vector, which will go ahead and calculate a new vector or it will change the vector properties based on what this vector got passed in. So we're not going to change the x at all. We're going to change the y. We're going upwards, which means we're going in a negative y direction. And let's go negative 100. Now we also want this to reflect how one of the things we have to be careful about is this update. Depending on if it's being triggered every 1/60th of a second or every 1/30th of a second, this will give us different values because we don't know exactly what the frame refresh rate of our monitor is, and most likely, unless we've changed settings, we're tied to our refresh rate. So we're going to scale this, and we're going to scale it by this game time object. So we get that elapsed game time, total seconds. So that tells us how much time has elapsed between the previous frame and this frame. And the other thing we're going to do there is convert this to a float, because that is a double by default. So this becomes a float. We multiply it by negative 100. That also returns a float because we're doing floating point multiplication, and that's going to change our y position. If we want to see this work, we can go ahead and come down, do .NET Run, or if you prefer, you can also use the button key there. Either one of those will do what we want. And now if I press the up key, you can see my ball goes up. So we'll want to do the same thing for all of our other keyboard directions. So keys dot down, and S for the WSD down direction, and instead of going negative 100, we're going to go positive 100, and then we'll do the same thing for the X and Y. Sorry, the left and right, I mean. So left would be A, oops, actually, up should have been W. There we go. WSA, and this should be D. And this should be right. And instead of moving in the Y direction, we'll want to move in the X direction. So we're going to flop those, and let's see, right would be positive, left would be negative, so our signs are correct. And once we've done that, now we're basically, anytime the key up key or W key is pressed, we're going to go up. Anytime the down key or the S key is pressed, we're going to go down. If the A key or the left key is pressed, we're going to go to the right. And if the right key or, sorry, the left, or if the right key or the D key, we're going to go right. So let's go ahead and see what that looks like. And we have all the motion we could want from the keyboard. So that's keyboard input. Let's go ahead and add gamepad input. So with our gamepad, we're going to use a gamepad state object, and we're going to call this current gamepad state. And then we go ahead and get into our code here. Let's say this is keyboard input. And we're going to add gamepad input. And we have to actually pull the device for that as well. Gamepad state equals gamepad dot get state. Now if you're wondering, keyboard and gamepad, these are static classes, so they're essentially static classes. These are static methods, so we can call them directly. They're more like a library than anything. Now one of the things that's a little bit different is notice that here we're expecting a player index 1, 2, 3, 4, 5, 6, 7, 8, and that is because we can have more than one gamepad hooked up to our device, and this specifies which one we're wanting. So when we start doing multiplayer, we might actually want to have more than one gamepad, one for each player. So we get into a little bit more complexity there. In a one-player game, it's generally going to be player index 1 is the one that we're going to be pulling, because that's going to be the one that we get hit, that powers up first. However, if there are more than one gamepad hooked up to the system, there is a possibility that the active one, the one the player is holding, is not actually index 1. So that is something that we can deal with down the road. We're not going to delve into it right now. We can assume that there's just one. But then we're going to go ahead and pull its state. And then we want to move our ball, but we're going to move our ball a little bit differently with the gamepad. So with the gamepad, and I'm going to move the second ball with it, we're going to actually say its position plus equals, and then we're going to take that current gamepad state dot, and notice all the different properties we have in here. We have our D-pad, we have our triggers, we have our thumbsticks, we have the is button down and up. We'll get to those in a bit, but we're going to use thumbsticks, and there are two. There's the left and the right. So we're going to use the right thumbstick. Now the thumbstick itself is actually a vector too. So this is indicating a value between 0 and 1 for the X and 0 and 1 for the Y, showing exactly where the game stick is connected. And that actually will vary between -1 and +1. So unlike the keys where we're just all on or all off, the thumbstick allows us to have a little bit of softness to the touch. And so we will take that position and we will scale it by 100, just like we did up here, times that cast to a float game time dot elapsed game time dot seconds times that current. So what actually happens here is we have 100 times a float, so we convert it into a float, and this seconds is going to be a very small fraction, so something like 0.018 or something. So this will become a small number, and then we multiply a vector 2 by that number, which applies that as a scaling factor to both the x and the y, and then we add that into our position, so that replaces or modifies the x by the x of this, and the y by the y of this. So that's really all we have to do to take the direction we're pushing on the gamepad and turn it into movement. And let me grab a gamepad real quick and I will show you what that looks like. And you're just going to have to take my word for it for now, because I realized I didn't have an Xbox or a gamepad controller available where I'm recording. So that's basically how we would set up a gamepad. If you want to use one, we do have a number that you can check out from the university. Just let me know. It's okay if you turn this in and you haven't actually tested it. That will not count against your grade. Okay, so moving on from the keyboard, the other device we'd want to look at is the mouse. And just like the other kinds of input, we do device pulling. And it operates pretty much the same way. Now you may have noticed there, oops, not gamepad, mouse pad. Not mouse pad, just mouse. Oh boy. And the assumption is you would only ever have one keyboard, one mouse plugged into a computer, whereas we would anticipate potentially multiple gamepads. Now the mouse has a similar idea to the gamepad, that it actually stores, gives us a X and a Y position of the mouse relative to the screen. So we're going to do this position, and we're going to set it directly to the mouse state. Oh, that is a point. So I think we're going to go ahead and construct a vector 2, and so we will just go ahead and take the position the mouse is registering, set that as the ball position. So if you want to see what that looks like, Now you can see our ball follows our mouse around. Also notice that the mouse itself is actually pointing at the upper left-hand corner. That's where the sprite's origin is. So it could be adjusted like we did in that first tutorial, or honestly we could just turn off the mouse cursor and the ball essentially becomes our cursor. But you do need to realize that the coordinate system comes into play there. And that's basically it for the initial part of this. Now let's go ahead and think about what if we pressed a button or a key and we wanted something to happen just once. And to kind of explore that, let's go ahead and jump back to our ball class, and let's add a new method to our ball class. I'm going to, public void warp. So this is going to just warp our ball to a brand new position somewhere on the screen, which means we want to have a way of generating a random number. And you've probably used the system.random before. There's also a mathhelper.random in XNA, and that's actually the one we're going to use. It's a slightly different algorithm for generating that. And we're going to go ahead and create this on the game object itself. So this is going to be a mathhelper.random. We'll call it random. And we are making it a public accessor. And I'm going to use the init. So we have a getter and an initializer. Initializer is allowed to be run only once, and we're going to go ahead and run it right here. And actually, we just need to construct a new math helper, and we can even use the shorthand syntax for just calling its constructor. So that would go ahead and set it. Once it's set, we can't change it anymore, and we have one random number generator which is shared amongst the entire game. Now this constructor can also be seeded. We can give it a particular number seed that's going to determine what that sequence is. And the nice thing about this random number generator, and also system.rand as well, is if you give it the same seed, it will always generate the same sequence of numbers, so it becomes deterministic, which is important if we're doing something like content generation, random content generation, but you want to be able to reload the same level that looks exactly the same if a player comes back later and loads from a save file without saving all of that information. Okay, so now if we jump back to our ball, we can now access that random number generator. So we're going to say our position and set it equal to a new vector2, and I'm going to go ahead and do these on separate lines just so they're a little easier to read, but I'll do that game.random.nextFloat, game.random.nextFloat. So that's going to be our X and Y. We're going to get some random values there, and we also want those to appear anywhere in the screen. That next float gives us a number between 0 and 1, so a fractional number. We'll go back to our game and get our graphics device .viewport .width for the X, and then game.graphics device .viewport .height. So that will scale basically from 0 to the width of our screen, and the same for the height. Now you notice that we were drawing our sprites with the origin at the upper left hand corner, so it is possible that they could appear just right on the very edge of the screen. So if we want to prevent that, we can also subtract from this height the texture dot width. And because order of operations says multiplication goes first, we need to wrap that in a parenthesis so that subtraction happens first, and this will keep it completely on screen no matter what. Okay, so that will update the position when this is called to a random spot somewhere on the screen. So let's go back to our game and trigger that. Let's start with the keyboard. We'll pick a key, and I'm going to use the space key. And if it happens to be down, I'm going to call warp on ball 0. So if I run this, and I press the space key, you can see our ball randomly warps to a position. Now I am holding down the space key when I let up, and this is an important thing to understand. Remember, our game is actually going through its game loop every 1/60th of a second. On most cases, it might be 1/30th or 1/120th, depending on your monitor refresh. But the average human being pressing that space bar, even if they're just trying to barely tap it, is actually going to be holding it down for multiple frames, which means at the start of every single one of these update calls that they're still holding it down, we're going to trigger this warp. So that is actually a problem for a lot of games, because we don't actually want that to happen. We want one press to equal one action taking place. And the way that we can deal with this is we need to actually keep not just what our current state is, but what our state was in the prior frame. And then we can watch for those changes where the key wasn't pressed, but now it is pressed, or the key was pressed, but now it's released. So we get to kind of pick and choose what we want to use for that. But to do that, we need to have a second state object. And I'm going to call that prior keyboard state. And at the end of our method here for the update, we're going to take our current keyboard state. We're going to set it equal to the prior keyboard state. Now, I'm not actually initializing prior keyboard state the first time, so it gets initialized, basically C# anytime we initialize a struct, but we don't give it any initial values. Everything gets zeroed out in memory, so all of this is going to be reading as no key is pressed, which is fine. And then the very next time we come through this frame, we're going to set the prior keyboard state to what we currently pulled. So every time we come through prior keyboard state, up here is going to be exactly what it was the last frame. So then we can come in here and say prior keyboard state dot is key up, so asking the opposite question, keys dot space. So here we're saying, was it the case that in the prior frame the key was up, but now it is down? So did it just go down between these two frames? And that is how we're going to catch that space bar press and have it just trigger once. Whoops, I must have missed something there. Is key down, key space, and prior keyboard state is key up. And only if those two things are true. And then, oh, I have these backwards. We should be setting the prior keyboard state to the current keyboard state. So now they are the same, and then the next time we come through, we grab the new keyboard state, and our prior keyboard state is the previous round. So now let's try that. And if I press the space bar, no matter how long I hold it down for, it only jumps once for each press. The gamepad, very much the same. Current gamepad state, buttons, A, let's see, let's warp on A. So if the A button actually is button state dot pressed. Now this is a little different because we're not getting is key up or key down. We're actually checking the state of that button, and it can be in two states, which is either pressed or not pressed. And we need a prior gamepad state. So we want the current state to be pressed and prior gamepad state dot buttons dot A button state released. So it was released in the prior turn, now it's up, and we'll go ahead and say balls 1 dot warp. and that will go ahead and warp our ball to a new position. And then of course we have to do the updating of the cached values. So prior gamepad state equals current gamepad state. And if we run this again, which I don't have a gamepad so I can't show you, but it should do exactly the same thing. And then finally, mouse input works pretty much the same way as well. And so we come in here. Prior equals current, and then we're going to check to see if the left click has been done. So if current mouse state dot left button equals button state pressed, and notice this uses the same button states as the gamepad, and prior mouse state dot left button state dot released. Then we're going to call balls to dot warp. And if we run this now, when we click that left mouse button, you can see there's a flicker, and what's actually happening is that ball is warping to a new position, but immediately that next frame it's being set back to the mouse position. Because remember, every frame we are updating the position of the mouse controlled ball to this ball. So what we might do instead, because that's not going to be very fulfilling, is swap this so that we actually warp the other two balls when we click the left mouse button. So I'll turn this into a 2-line if branch. And now if we run that, and click the mouse button, the left mouse button, you can see every time I click, both of those balls move to a new position. When I do the space bar, just the orange ball, or when I do the A button on the controller, just the green ball. So those are the basic way that we can pull and grab input from all the different devices that we potentially have to deal with. And this should be enough to get you started. Now you'll notice this is starting to get a little messy. We've got a whole lot of extra variables in here. If you remember your dry principles, do not repeat yourself, and keep it clean, and all of the good software design principles, you probably are starting to think, I could take all that input information and put it into a separate input class that I initialize once. I call its update method, I call its and then I can grab all the information I need out of it for my game, and that's absolutely a good way to go. One of the other things I will point out, especially with mouse input, a lot of times we don't actually want to use the X and Y of the mouse. We want to know what the delta is, how much the mouse has moved from the previous frame to the current frame, and we use that to actually update our position. If you wanted to do something like that, it's pretty much just take the current mouse state and subtract the prior mouse state, and that gives you a delta of how much it's changed. So that's another way you can use that. But this is just a working example to get us a little familiar with input. This should give you enough that you can start actually processing input and using it in your games. And that is where we will stop for today. Oh, yes. But for those of you that are actually doing this for a class assignment, the next step would be to actually put this all into Git. So I'll walk through that just on this one because it's the first time we've done it. Actually, I'm not going to do that. I'm going to point you at a video that just does the turn-in. So if you go and look at your assignment in Canvas, there is a separate video that has to do with creating a release and uploading your code and making sure that that's all taken care of. And that'll be on every exercise, so you can always go back and look at it. So yeah, that is where we're going to stop for today. I hope you enjoyed yourself and learned something.